Time travel is not forbidden by modern physics, but it is tightly constrained by its fundamental laws. According to general relativity, time does not flow. It is a rigid dimension embedded in spacetime itself. In one serious interpretation known as the block universe, past, present, and future are not possibilities. They are coordinates inside a fixed geometric structure. Moving through time, then, is not a journey. It is an attempt to operate outside the configurations the system allows. To do that, you must confront three limits that cannot be negotiated: the speed of light, energy on a stellar scale, and the irreversible constraints imposed by entropy. This is not science fiction. This is the real physics of time travel and the cost of testing it. And here is the unsettling fact. You are already inside a system that corrects time every single day. At this very moment, the device in your pocket is actively correcting a temporal error you cannot perceive. If it stopped, your world would effectively lose its coordinates. We rely on the Global Positioning System, also known as GPS, to navigate our lives, assuming that time on Earth and time in space are identical. They are not. The satellites orbiting 20,000 kilometers above you are moving at high velocities, which according to special relativity slows their internal clocks by 7 microseconds a day. However, they are also positioned in a weaker gravitational field than we are on the surface, which under general relativity causes their clocks to tick 45 microseconds faster. The net result is a system deviation of 38 microseconds every single day. To a human, 38 microseconds is nothing. But to a navigation system synchronized at the speed of light, it is catastrophic. If engineers did not program the satellites to continuously offset their clocks, effectively compensating for relativistic time dilation, the entire GPS network would accumulate a drift of 10 kilometers per day. By tomorrow, your map would tell you that your house is in the middle of the ocean. This daily correction is the most tangible proof we have. Time is not a universal constant. It is a variable that can be stretched and compressed by the configuration of the system. This reveals a profound truth about our reality. Time is not a ghostly, abstract concept that flows independently of matter. It is a physical structure as real in its effects as any material framework we interact with. When Albert Einstein formulated his theories, he did not merely discover a new way to measure the clock. He uncovered the underlying architecture of the cosmos. He revealed that space and time are woven together into a single four-dimensional fabric known as space-time. In this model, gravity is not a force, but the curvature of the fabric itself. Therefore, the question, is time travel possible, is technically the wrong question. We are already traveling through time at a rate of 1 second per second. The real question is whether we can alter our trajectory through this massive concrete architecture. Can we accelerate our slide into the future? Can we tunnel back to the past? Or are we permanently locked into a script that has already been written? To understand why time travel is difficult, we must first accept that our perception of now is a biological trick. We feel time passing like a river flowing past a stationary observer, but physics offers a radically different blueprint, the block universe. In 1908, mathematician Hermann Minkowski proposed that space and time are not independent variables, but fused into a single four-dimensional manifold. Imagine the history of the universe not as a movie playing out frame by frame, but as a solid block of ice. In this static architecture, the Big Bang is at one end, and the heat death of the universe is at the other. Every moment between them, the dinosaurs, the Roman Empire, your birth, and your eventual death exist simultaneously at fixed coordinates x, y, z, and t. Think of reality like a vinyl record. The entire song is already pressed into the groove. The needle reads only one specific point at a time, creating the sensation of music playing. But the beginning and the ending of the track exist physically on the disc at the same moment. In this model, the past has not vanished. It remains a fixed region within the space-time structure. The future has not yet happened to you, but the structure is already mathematically defined. This geometric reality introduces a terrifying constraint, world-line rigidity. Your existence through this block is represented by a world line, a continuous path winding through space-time. Because the block is static, your world line is not a road you drive on with the freedom to steer. It is a rail you are locked onto. From the hyperspace perspective, you are not a dynamic being making choices. You are a completed data structure, a long worm-like entity stretching from birth to death. The ink is dry on the blueprint of your life before you even perceive it. However, we are not trapped in a total stasis. We perceive change. We perceive aging. This suggests that while the coordinates are fixed, our trajectory through them is governed by specific variables. If the structure is composed of immovable coordinates, how can we explain the sensation of movement? To answer that, we must look at the first variable that allows us to slide along these rails: speed. If the block universe is a frozen landscape, then velocity is the mechanism that determines how our proper time diverges from the surrounding spacetime. Einstein's theory of special relativity dictates that the speed of light, called c, is the absolute constant of the universe. To ensure that c remains the same for all observers, the universe is forced to adjust the other variables. Space must contract, and time must dilate. This is not theoretical. We have already sent a human being into the future. Cosmonaut Sergei Krikalev holds the record for the most significant verified time jump in human history, spending a cumulative 803 days aboard the Mir space station and the ISS orbiting at approximately 7.66 kilometers per second. Krikalev triggered a measurable desynchronization from Earth's timeline. While his biology continued ticking at its normal rhythm, the high velocity caused his internal clock to run slower relative to the stationary ground. Upon his return, calculations confirmed that Krikalev had aged 0.02 seconds less than everyone else on the planet, which is about 20 milliseconds. Technically, he did not travel to the future. He slid there. Think of this phenomenon like sliding on frictionless ice. The faster you move through space, the slower you move through time. Krikalev's slide was microscopic, a mere fraction of a breath, but it proves the system allows forward migration. It is a one-way exchange rate. You purchase distance in space by selling your time. But what happens if we push this variable to its system limit? If we accelerate not just to orbital speeds, but to the edge of the light barrier? In 1991, detectors in Utah recorded an anomaly that shattered our understanding of energy limits, the "oh my God" particle. This was a single proton likely ejected from a supermassive black hole, screaming across the cosmos at 99.99951% of the speed of light. At this velocity, the relativistic time dilation factor grows without bound as velocity approaches the speed of light. From Earth's perspective, this particle took millions of years to cross the void between galaxies. But from the particle's own frame of reference, the journey was instantaneous. It did not experience time. It did not age. From its own frame of reference, the interval of proper time along its path approaches zero. This reveals the ultimate constraint of the velocity variable. As you approach light speed, time freezes. If you could become a photon, the interval between the universe's early and late states would collapse towards zero proper time. You would encompass the entire block universe at once. However, this mechanism reveals a critical flaw for anyone hoping to fix their past. Velocity only functions in one direction. You can slide forward into the future as fast as your energy allows, leaving the present behind. But speed allows no U-turns. Speed allows no rewind. To go back, you cannot simply move faster. You must break the geometry itself. If velocity is a dead end for backward travel, we must abandon the idea of moving through space and instead focus on manipulating the shape of space itself. General relativity is not just a theory of motion. It is a theory of geometry. Mass tells space how to curve, and space tells mass how to move. If we can configure matter in a specific enough arrangement, we can theoretically manipulate space-time geometry so that two distant coordinates become locally adjacent. This topological circumvention is known as the Einstein-Rosen bridge, or more commonly, a wormhole. In this configuration, the traveler does not need to exceed the speed of light to reach the past. Instead, they step through a tunnel that connects one point in space-time, the present, directly to another point, the past. The effective space-time separation between them collapses to a negligible interval. Similarly, the Alcubierre warp drive proposes contracting space-time in front of a vessel and expanding it behind, creating a bubble that surfs the fabric of reality faster than light, without locally breaking the speed limit. Mathematically, the system permits these structures. The equations of general relativity admit valid solutions for such geometries. There is no error message in the geometry. However, geometry is only the blueprint. To build the structure, you need materials, and this is where the system presents a bill that humanity cannot pay. To maintain a stable wormhole, you must force the throat of the tunnel to stay open against the crushing weight of gravity. Normal mass and energy produce attractive gravity, which would pinch the tunnel shut the instant it formed, obliterating any traveler inside. To prop the door open, you need a form of energy that produces repulsive gravity, something with a negative energy density. In theoretical physics, this requirement is often described as exotic matter. It is not fiction, it is a requirement of the system's stability protocols. We have observed hints of this phenomenon in the quantum realm via the Casimir effect, where two metal plates placed nanometers apart in a vacuum create a measurable negative pressure due to the exclusion of vacuum fluctuations. But here lies the scale gap, the immense disparity between what is possible and what is required. The negative energy observed in the Casimir effect is microscopic, measured in piconewtons. The magnitude of this negative energy is many orders of magnitude below any macroscopically useful scale. In contrast, to keep a wormhole throat just 1 meter wide and stable enough for a human to pass through, calculations suggest you would need negative energy equal to the mass of Jupiter, about 1.89 times 10 to the power of 27 kilograms, converted entirely into exotic matter. This is the galactic mortgage. The system does not strictly forbid you from building a bridge to the past, but it sets the price so high that it renders the attempt economically impossible for any civilization less than a Kardashev type Tau Tinto. We are like ants trying to build a nuclear reactor using only the calories from a breadcrumb. Yet let us assume for a moment that we could pay this debt. Let us assume we harvest a star engineer, a configuration that produces a sustained region of negative energy density, and stabilize the tunnel. Even if you manage to bypass the velocity limit and pay the energy cost, the universe has one final invisible wall waiting on the other side. When we examine the fundamental laws of physics, from Newton's mechanics to Schrödinger's quantum equation, we find a strange symmetry. They are time neutral. If you play a video of planets orbiting a star or billiard balls colliding backward, the equations still work perfectly. At the level of fundamental equations, the system does not encode a preferred temporal direction. Yet in our macroscopic reality, we never see a shattered teacup reassemble itself. We never see smoke swirl back into a matchstick. Time has a distinct, ruthless direction. This directionality is not dictated by gravity or speed, but by the second law of thermodynamics. This law functions as the dominant macroscopic constraint on physical processes. It states that within a closed system, entropy, the measure of disorder, must always increase, or at least stay the same. In other words, delta S is always greater than or equal to 0. The universe relentlessly moves from ordered states with low entropy toward disordered states with high entropy. Consider the egg. An intact egg is a highly ordered configuration. A smashed egg is a disordered one. The reason the egg never unsmashes is not because physics forbids the atoms from retracing their paths, but because the probability of them doing so by chance is so infinitesimally small. An astronomically small probability, effectively indistinguishable from 0 on any physical timescale, that it is effectively 0. This is the irreversible verdict. The arrow of time is a statistical mandate. To travel backward is to swim upstream against the entire thermodynamic current of the cosmos. It requires forcing a high-entropy universe back into a low-entropy configuration. The system naturally evolves toward higher entropy states, and it resists any attempt to restore previous versions of itself with a rigidity that makes concrete look like water. This thermodynamic barrier creates a massive problem for any potential time traveler, a problem we can call the contamination rule. Imagine you successfully build a wormhole and step through it to the year 1920. You are not just a passive observer. You are a physical object composed of matter and energy from the year 2025. You originate from a future state of the universe that has higher total entropy than the past you are visiting. Biologically and thermodynamically, you are a hot object entering a cold room. By simply existing in the past, your body heat radiates energy, your lungs exchange gases, and your presence displaces air molecules. You are introducing a chaotic variable into a highly ordered system. In system terms, you are a thermal virus. You are importing foreign entropy into a closed environment that does not have the capacity to process it without violating the second law. Many physicists, including Stephen Hawking with his chronology protection conjecture, argue that the system has an automated defense against this intrusion. Just as a biological immune system attacks a foreign pathogen, the universe may react to this thermodynamic violation by destabilizing the mechanism of travel itself. This could manifest as a feedback loop of vacuum fluctuations radiation, building up between the two mouths of the wormhole until it triggers a system rejection. The energy density spikes, the wormhole collapses, or the radiation sterilizes the traveler before they can cross the threshold. This is not the universe acting with malice. It is the system rebalancing its equation. The state of you in the past is energetically unsustainable. Thus, the barrier is not just about building a machine, it is about obtaining a thermodynamic visa that the laws of physics refuse to issue. You cannot simply walk into a clean room covered in mud without the room becoming dirty, and the past represents a low entropy configuration that cannot absorb uncontrolled perturbations. And yet, if you somehow manage to shield yourself, bypass the entropy alarms, and force your way into yesterday, you face the final, most absolute gatekeeper. If physics fails to stop you, logic itself will intervene. If you somehow possess the infinite energy to warp space-time and the shielding to survive the thermodynamic shock, you arrive at the final consistency constraint logic. The universe functions like a coherent data processing system. Cause must always come before effect. This chain of causality is the bedrock of reality's operating system. Backward time travel, by definition, reverses that order, placing the effect before the cause, and creating what system analysts would call an unresolvable consistency error. Consider the classic grandfather paradox. In this scenario, you travel back and prevent your grandfather from meeting your grandmother. Consequently, your father is never born, and neither are you. But if you are never born, you cannot travel back to intervene. So your grandfather does meet your grandmother, you are born, and you do travel back. This is not just a philosophical riddle, it is an inconsistent causal loop. The system receives one input that says you exist and produces an output that says you do not exist. In computational terms, this represents a non-convergent logical state. The universe cannot calculate a stable state for reality because the variables are oscillating infinitely between two mutually exclusive outcomes. Even more disturbing is what physicists call the bootstrap paradox, also known as a causal loop. Imagine you travel to 1800 and hand a young Ludwig van Beethoven the sheet music for his Fifth Symphony. He copies it, publishes it, and becomes famous. Centuries later, you buy that music and take it back to him. The question arises, who wrote the symphony? Beethoven didn't. He copied you. You didn't. You copied Beethoven. The information exists without an origin. It is a data object trapped in a recursive loop without a well-defined causal origin. For a physical universe built on conservation laws, receiving information from nowhere is as incompatible with conservation laws as spontaneous energy creation. These paradoxes represent corrupted data sectors. If the block universe is rigid, it cannot tolerate these inconsistencies. Therefore, the system must have a debugging protocol and autocorrection mechanism to handle the glitch. How does the universe resolve a fatal error? Theoretical physics offers two primary patches for this bug. The first is the Novikov self-consistency principle. Russian physicist Igor Novikov suggested that the probability of any event generating a paradox is strictly zero. The system forces consistency. If you try to shoot your grandfather, the gun jams. If you try to build a bomb, the detonator fails. Your actions are dynamically constrained to preserve consistency, physically incapable of altering the established coordinates. You are not a traveler, you are merely fulfilling the loop that was always written, but quantum mechanics offers a more radical solution: system branching. According to the many worlds interpretation of quantum mechanics, the universe is not a single thread, but a continually branching structure of quantum outcomes. Every quantum event causes reality to split. When applied to time travel, this removes the paradox entirely by creating a new instance. When you step out of the wormhole into the past, you do not arrive at your own past. The instant you appear, the system splits, creating a new and divergent reality, separate from the one you came from. In Timeline B, you can prevent your grandfather's meeting. You can act freely. Your actions will reshape the future of Timeline B. However, your original timeline, Timeline A, the one where your grandfather lived and you were born, remains intact and inaccessible. You have not changed the past. You have merely created a new future. This solves the logical conflict, but it exacts a heavy psychological price. By entering the past, you permanently disconnect from your origin. You become a cosmic castaway, stranded in a copy of history. The you in Timeline A is simply gone, remains confined to its original branch, inaccessible to you, while the you in Timeline B is an anomaly in a universe that is not your home. The system remains stable because it isolates the error. It allows you to have your choice, but it quarantines the inconsistency within a separate causal branch to protect the integrity of the main file. When we step back and view the architecture of time in its entirety, the conclusion is sobering. The universe does not appear to be a playground designed for unrestricted travel. It is a fortified system built on stability, continuity, and conservation. We have climbed the ladder of constraints, and at every rung we found a new mechanism of resistance. The geometry of the block universe locks our history into rigid coordinates. The velocity variable allows us to slide into the future, but forbids any return. The energy barrier demands a galactic ransom to even open the door. The thermodynamic laws reject our presence in the past as a violation of order. And finally, logic itself stands ready to quarantine us in divergent timelines to prevent a system crash. From a purely engineering standpoint, building a time machine is an attempt to force the universe to perform an operation it was never configured to execute. It is an exploit, a hack against the fundamental code of reality. And like any robust system, the cosmos has layers of defense to neutralize the intruder. However, the fact that the laws of physics do not completely forbid the attempt, that they leave open the microscopic loopholes of wormholes and quantum branching, reveals something profound about our place in the cosmos. We are creatures trapped in a rigid structure, yet we possess minds that demand the freedom to rewrite it. We are obsessed with time travel not because we want to see dinosaurs, but because we want to regain the power of choice. We want to undo the mistake, save the loved one, or unwrite the tragedy. Physics offers us a compromise, but it is a brutal one. The many worlds interpretation suggests that you can have your choice. You can create a version of the past where a different outcome occurs. But the cost is absolute exile. To change history, you must abandon your own. You must sever the causal link to the timeline that created you and drift into a new, parallel instance of reality. You cannot heal the wound in your original universe. You can only start over in a new one. Perhaps this is the final lesson of the system. The ink of the past is dry and the structure is set in stone. The cost of regaining the power of choice is not just energy or speed. It is the willingness to leave everything you know behind and to accept the terrifying freedom of a brand new universe.